Hey everyone. So if the quadratic equation is given to us, it has two equal real roots. Find the value of k. So immediately I see that we have to use the discriminant. This is the key term, discriminant. I mean, two equal real roots. And for discriminant, immediately I know we have this equation. So what we can do in here, we need to identify our ABC. So let's put this quadratic equation in the form of a squared plus b, sorry, ax squared plus bx plus c equals to 0. Let's do that. So we have x squared minus 8x equals to k, x squared minus 8x minus k equals to 0. Then we can say a equals to 1, b equals to -8, c equals to -k. Therefore, discriminant will be -8 squared minus 4 times a times -k. And I can simplify everything. This will be 64 minus or plus 4k. And it says that it must have two equal real roots. That's why we need to let it equal to 0. And now I can solve for k. So let it equal to -4k. K would be -8. No, I lied. It should be -16. Because 64 divided by 4 would be -16. So let me color everything. In here, we just rearranged. So rearrange. And the purpose of that, to get A, B, and C. That's our purpose. So we have yellow, green, and let's say pink. So once we have these, we'll just put it back into the discriminant form. Let's B. And then finally we have A. And the last one in here, let's say purple, two equal real roots. That would be the equal to 0. That's the reason that we let it equal to 0, because it says two equal real roots. So you need to note the 3 different conditions. No roots at all, which is less than, the discriminant would be less than 0. And then one real root would be repeating, remember? And then 2 would be equals to 0. And this is the repeating. Sorry, 2 would be greater than 0, and this is repeating. You know what? Let me just write it down. Discriminant greater than 0 equals to 0, 1 solution, 2 solutions, and no solution. So if it has 2 equal, this will be 2 equal real roots. That means we have 1 solution because they're equal. Okay, let's move on. Let's move on to the next question. So consider the graph of the following functions. Okay, we are given these two quadratics. Which of these graphs are wider? Okay, so in here, we need to look at the a value, remember? So y equals ax squared plus bx plus c. A determines the width. That's transformation. Remember, A is called the vertical stretch. A is the vertical stretch, meaning that if A is 2, it is wider than A is 1. Therefore, equation 1, just write it down, is wider than equation 2. So this is just definition. Do the two graphs have the same y-intercepts? Okay, so we can just find out. Y-intercept is when x equals to 0. So when we have y equals to 2x squared minus 8 for the first one, then we have 2 times 0 to the power of 2, and that would be negative 8. And for the second one, same thing, 0 to the power of 2 minus 8, and that would be negative 8. Therefore, yes, same y-intercept. Last one, find the x-intercept of graph A. So, graph 1, I mean. So x-intercept is when y equals to 0. So let's pop it in. So y equals, for 1, 2x squared minus 8. And we have 0, and then 2x squared minus 8. We can factor out the 2. And this will be the difference of squares. Therefore, x will be plus or minus 2. So x-intercept are x equals to 2 and x equals to negative 2. And we're done. So this will be part AB. This will be part C.